let's figure out how to add the nonce value, which is a crucial aspect in enabling the proof of work system. The nonce is a value that is included as part of the calculation of the hash for the block. By changing this nonce value, miners can continually generate new hashes with a number of leading zeros that match the current difficulty of the blockchain system. Let's start by declaring the overall difficulty of our system in the block.js file though. So let's declare a difficulty constant that will be all uppercase so it's very noticeable, and let's set it to 4. And then we'll add a new parameter to our block class, which is the nonce value. So once we have our nonce parameter after the data, we'll also bind this .nonce to the given nonce value in the constructor. Now that the nonce value is a part of the block, we should include it within the calculation of our hash values. So first off, in the static hash function at the bottom, let's have a nonce parameter after data. And likewise, we'll also include the nonce as part of the SHA-256 input that is created overall from all of the parameters. Likewise, we'll update our block hash function to also get the nonce value from the given block, and then pass it as an argument to the block.hash function that is being used and returned in block hash. Let's also include the nonce in our toString function. So before data actually, let's have our nonce, make sure these colons are aligned, and then using the template string $curly brace syntax, let's input this .nonce. Finally, we have to consider our genesis function, which should create a default nonce value, and for us, the default one will be 0. Alright, now that we have a nonce value for our blocks, we need to include it within new instances of this block class. Recall that the nonce value is going to be used in the generation of the hash until a hash is found with a number of leading zeros that match the current difficulty of the blockchain system. We create new instances with the mineBlock function. In this function, let's start out with a nonce value of 0, and we'll use a let variable to do that, so that way this nonce value can be reassigned later and changed. So declare let nonce is 0. Now we'll want to use this value as we generate our hash. So let's cut this const hash value, or line rather, and paste it after our nonce. And then let's input the nonce as part of our calculated hash. All right, great. This should generate a new hash for this block based on the extra nonce value, which at this point is 0. However, we're not guaranteed that this hash will have a number of leading zeros which passes our proof of work condition. Therefore, we need to continue generating new hash values based off of new nonce values. To do so, we'll run a loop that both increments the nonce value and generates a new hash until the hash actually passes our condition by starting with the right number of leading zeros according to the difficulty. To accomplish this, we'll have a do while loop, which will allow us to execute the generation of the hash at least once before we check if it passes our condition. So that's do while. Let's grab these lines and place it within the do while loop. Outside of the do body, we'll have the while condition over here. In the body of this loop, we're going to run nonce ++ and continue to declare let nonce equals 0 outside. So make sure let nonce equals 0 is outside. And in the body of this loop, rather than recreating our const hash every time, we'll reset the hash. And now at the top of our mineBlock function, we're using a hash constant that doesn't exist yet. So let's declare a hash variable that can be reassigned every time we iterate through our do while loop. Next, it will probably take a considerable amount of time to generate this block, considering that we're creating a proof of work algorithm now. Thus, we should recalculate the timestamp at every iteration of this loop. Therefore, let's also make the timestamp declared before. And now within the body of our loop, we're going to recalculate the timestamp at every iteration. Finally, we add our proof of work condition in the while loop. We'll make sure that the loop only breaks once a hash value is found, with leading zeros that match the difficulty of the system. To do this check, we'll take a substring from 0 up to the difficulty constant that we declared at the top of the file. So we're going to check that the hash substring from 0 up to the difficulty, and then the while condition makes sure that the do while loop runs as long as the condition is met. So let's say as long as this hash is not equal to 0.repeat up to the difficulty, then we're going to run the loop. Repeat is a convenient method which takes a character and returns back a string up to the number that we provide to the function, which is 4 because that is the current difficulty. And then this check is the proof of work algorithm in action. So we take the substring of the generated hash and we make sure that it matches a certain number of leading zeros up to the blockchain's difficulty. Finally, let's include the nonce value in the creation of our block instance with the return statement of this MineBlock function. All right, with that, we have the first part of our proof of work system in place that ensures blocks are generated with the proper hash value to match our leading zero condition. By adding a loop to generate these hash values, we're demanding that the node requesting to mine a block is actually spending computational power to find this hash value. Moving on, let's test this new feature of our MineBlock function and make sure the nonce value is generating an adequate hash value in our expected format of the leading zeros.